Welcome. This is the emission spectroscopy lab for segment 1. This is Alexis Winkler
and Marissa Kahn. In segment 1, we will be exploring what properties of the dye molecule or system controls the lambda max.
What is lambda max? As seen in the emission spectra, the lambda max is the highest peak, which correlates to the greatest relative intensity at a given wavelength. The wavelength is dependent upon the energy of the photon. For example, if the photon has a high energy, then the corresponding wavelength will be short. At that given wavelength, an emission intensity value is produced. Emission occurs when the electrons relax to the ground state, which releases photons of a given wavelength. The emission intensity is proportional to the number of photons being emitted. Therefore, the lambda max is when the greatest number of photons with a specific amount of energy are being emitted. One property that controls the lambda max is the absorbance, the excitation of electrons. As seen in the video, when a ball is dropped from a certain height, it never gains all of the height back because of the loss of energy. Likewise, in emission, the substance can never emit more than it absorbed. Therefore, the emission lambda max is dependent upon the amount of photons that was originally absorbed by the substance.
A property that determines lambda max is the dye molecules. The observed color of a substance can be different than that of the actual dye molecules in the substance. In the glow stick lab, the green and red dyes had individual peaks and were observed to be the dye colors, red and green, whereas the mixture of red and green appeared to be yellow. However, the emission spectra displays two peaks, one that has a lambda max that correlates to red and one that correlates to green. Therefore, the lambda max is related to the dye molecules and not the observed color.
Now that we've explored the properties of lambda max, we will look at what determines the observed color of a substance in respect to mixtures. The mixture appears to be yellow rather than red and green because human eyes are unable to detect the different photon wavelengths that are being emitted by each dye molecule. Therefore, the observed color of mixtures can have two or more different lambda max values because they correspond to the lambda max for each individual dye molecule.
In conclusion, the photon wavelengths are dependent upon the discrete amount of energy that is released during electron relaxation. Additionally, the photon wavelengths correlate to the color of the substance. Lambda max is representative of the photon wavelengths that correlate to specific dye molecules.